So question 15. A quadratic function f is defined on R set of real numbers. Diagram 1 shows part of the graph with equation y equals f of x, and the turning point is 2, 3. Diagram 2 shows part of the graph of the equation y equals h of x, with the turning point is 6, 7. And we're told, given that h of x is equal to f of x plus a plus b, write down the values for a and b. So what does this mean? Well, this just means this graph is the same as this graph, except it's been shifted by some value a and raised by some value b. So how do we answer this? Well, we're told this expression h of x equals f of x plus a and plus b. So when it's inside the bracket here, it means it's going to be shifted. The plus sign means it's going to be shifted to the left, okay? And then this b plus b just means it's going to be shifted upwards. So if we look at the values that we have for the turning point, we've got 2 and 3 for f of x, and for h of x, we have 7 and 6. So from 2 to 7, it's been shifted. So it's been shifted by 5, and then for b, we can see that this has gone from 3 to 6, which is the value of 3. And the reason I've put them in brackets is because that's the absolute value. So the thing we need to think about here is usually when you've got this plus sign, it means that it's moving it to the left, okay? But here it's moved to the right. So our value of a is going to have to be minus 5, and our value of b, because it's just moving up, is still going to be 3. So you could write the expression, so f of x minus 5 plus 3 equals h of x. But they're just looking for these two values here, and it's 1 mark for each value. Okay, on to part B now. Part B. It is known that the integral between 3 and 1 of f of x is equal to 4. So what does that mean? Well, basically that just means that the area inside here is equal to 4, and we're asked to determine the value of h of x when it's the integral is taken between 6 and 8. So we're basically being asked what is the area here and here in this expression. So if you look here, this is simply just being moved along and moved up. So this area here is still going to be 4, okay? And if you look, we just want to know the dotted lines here. So this, and the difference there is 2, and the difference there is 3. So all you need to do is multiply them together and you get 6. So I'll just write this out over here so the working's proper. So you're told that the integral between 3 and 1 of f of x, f of x dx, is equal to 4. And we're also told that the integral between 8 and 6 of h of x dx, and we want to know this. Well, that's just going to be equal to 4 plus 6. So that's just equal to 10. That's your final answer there. So part C. Given that f-1 equals 6, state the value of h-8. So f-1 equals 6. f-8 equals equals what? Well, that just basically means that the gradient at this point, I'll change the color, the gradient at this point here is going to be equal to 6. Okay, so the gradient at point 1 is going to be equal to 6. Actually, this is not the question, it's h dash, my apologies, h-8. Okay, so, and we saw from our previous questions, when you go transform the equation to h, this point just moves here. So this is also going to be m equals 6 at h of 6, okay? And because of the line of symmetry, when this equation comes down and goes through point 8, it's going to be exactly the same, except it's going to be in the opposite direction. So m is going to equal minus 6. So your final answer here is going to be h with 8 equals minus 6. Right, and you just get your 1 mark there for stating that.